Hello there. It's March 21st, 2021, over a year since the beginning of the pandemic. Here we are with a new video. This video will deal with microphones and microphone technique, especially as it relates to ham radio. This will be a greatly simplified survey of modern microphone design and usage in amateur radio. We won't deal with the impedance variations of vintage radios or the use of compression, processing, or the mic gain settings of any particular radio. I'll likely do a different video dealing with those things. And remember, these are just the opinions of me. I'm Michael Farrow, K1MIX. I'm located in the San Fernando Valley, just north of Los Angeles. Over the last 50 years, I've been able to work in some of the best recording studios in the world, using all sorts of different microphones, recording all sorts of different instruments, and I've gotten to know the benefits of each design. There are two basic types of microphones: dynamic and condenser. The dynamic microphone we'll deal with is the moving coil design, which has a diaphragm which responds to sound pressure. That diaphragm is connected mechanically to a coil which moves inside a magnetic field. And when it moves inside the magnetic field, it generates a current or audio signal. The condenser has an electrically charged capsule. The diaphragm can be much lower in mass than the dynamic. The advantages of each type of microphone: the dynamic microphone is typically quite sturdy, will tolerate very high sound pressure levels, and there's no need for external power. Because of its lower mass diaphragm, the condenser has greater sensitivity, extended frequency response, excellent transient response, but to us in the radio community, the most important thing is it has a higher output level than the dynamic. Here are some dynamic mics typically used in a recording studio. On the left is the RE20, which is very popular with announcers, and in the upper right is the SM58, which is used by a lot of singers on stage. Here are some dynamic mics we use in ham radio: the Heil Gold line, the ICOM 151, the Yaesu MH31, and the Heil PR40. Condenser microphones that we use in recording range in the low end from $150 or so to the high end of above $15,000. Here's some condenser microphones we may want to use on ham radio. The MXL on the left typically costs around $75, and the BM800 on the right lists for about $25, but I'm using one right now, and I paid $12 for this one. More condenser mics we use in ham radio. Yeah, I know, I told you they were dynamics, but these particular dynamic microphones were modified by Bob Nagy in Arkansas. His call is AB5N. He's really a cool guy, and he converts dynamic mics into condensers. His website, 7000mic.com. Yeah, all this is very interesting, but what does it have to do with ham radio? The typical audio bandwidth of ham radio is about 100 Hz to 3 kHz. And here is a frequency response graph of a typical high-quality condenser microphone. You can see the frequency response is from 20 Hz to above 20 kHz. But most of that is just kind of a waste of time, energy, and money, because this is the useful range on ham radio. Here's some frequency response graphs of two high-quality ham radio mics. On the left is the Yaesu MD100. You can see it starts off life being very flat from 100 to 1 kHz, with a very dramatic rise up to about plus 10 at 2.5 kHz. On the right side, we see the Heil PR40, which once again is flat from 100 Hz to 1 kHz, and has it rise to about plus 5 at 3K. So why such a big boost around 3K? Human hearing is most sensitive in the 500 Hz to 4 kHz range, and speech clarity is highly dependent on the 1K to 3K range. The fundamental frequency of the typical male voice is around 100 Hz. That's the first bass A in the bass clef, with the second harmonic in the 200 Hz range. So which mic to choose? If we look at frequency response, what do we need? For FM rag chew, flat between 100 and 1K with a slight rise at 2.5. For DX, more of a roll-off on the low end and a significant rise in the 2K range, let's say about -5 at 100 and +6 or more at 2.5 kHz. Should we choose a dynamic or a condenser? It depends almost entirely on the radio. Most modern radios can deal with the output level of the dynamic, but some older models are happier with a condenser. The condenser's transient and extended frequency response are of little benefit on the radio. Great, we've chosen a microphone. Now we need to figure out how to use it. Microphone polar patterns, okay. Cardioid, unidirectional. Figure 8 is bidirectional. And the omnidirectional. You may recognize the omnidirectional from the Hudsucker Proxy, for kids. Okay, why do we care about polar patterns? What we think of as presence is primarily the ratio of direct sound to indirect or reflected sound. The more reflected sound the mic picks up, the less present your voice will sound, the more hollow and echoey, like somebody on a speakerphone. The cardioid pattern will increase presence by reducing off-axis sound. Distance from the mic will also affect it. Closer is better. Up to a point. What is that point and why? Okay, let's talk about plosives, fricatives, and proximity effect. Fascinating topic. Plosives and fricatives are basically wind noise. Plosives are consonants made by stopping the air, like pop, girl, car. Those are examples of plosive generators. Fricatives are consonants made by forcing high-speed air through a small opening. Fish, sit, 73. These are fricative generators. Microphones don't like either of these and will distort easily. How many times have you heard operators that sound like they're spitting into the mic? Very hard to listen to. Proximity effect is the increase in low-frequency content when a cardioid mic is used very close to the source. This doesn't help clarity, and talking too close can overload the mic amplifier stage due to an increase in sound pressure level. What to do? Well, let's start by keeping your distance. Well, it doesn't have to be 6 feet, but somewhere between 2 inches and 6 inches should work well for most mics. Most importantly, avoid speaking directly into the mic. This will greatly reduce the wind noise, plosives and fricatives. For hand mics, position the diaphragm at a 90-degree angle from your mouth and hold it as though your thumb could touch the corner of your mouth. Use whatever distance is appropriate for your voice. In this picture, you can see that the mic is close to the corner of the mouth, but outside the direct stream of air. The same technique with a handheld. Radio is close to the corner of the mouth, but outside the direct stream. On a boom, the mic points at the corner of the mouth, but outside the direct stream of air. I see a pattern here. Handheld mics pointed at the corner of the mouth and outside the direct stream of air. I'd very much like to thank Grizzly Adams with his COVID haircut for the mic demonstrations. In order to avoid directing the wind stream directly at the diaphragm, we need to know where the diaphragm is. Is it side addressed or is it end addressed? On the left, we have the MXL 990, which is a side addressed mic, and on the right is the RE20 end addressed. Some additional help for plosives, you can use a pop filter or a pop screen. Okay, now that we've figured out the microphone, what about our voice? People have told you, use a normal speaking voice. What they really mean is, don't shout. Use a normal speaking voice, but not the one you use speaking with your significant other. Speak as though it is to a group of friends. It'll be a little stronger. Try to keep your speaking volume relatively constant, as though your voice had some light processing on it. Don't be a boring monotone. Be sure not to talk too fast. This is a very common problem with topics you're very familiar with, like your call sign. By selecting an appropriate mic and using good mic technique, we can all sound good. This is K1MIX signing off and wishing you happy radioing.